Okay, so with the sloped field for this one, where dy on dx equals 0, that would be where x equals 0 and y minus 2 equals 0, x equals 0 and y equals 2 equals 0. I'll say y equals 2. They call this y equals 2 the constant solution, because what happens is in that differential equation, if you differentiated y equals 2, you get 0, which is the same as if you had dy and dx, and you put in y equals 2, you get 2 minus 2, which is x times 0, so that's 0. So on a slope field, all the way along the line where y equals 2, so you go 1, 2, all the way along here, there needs to be like a horizontal line. So that will be a horizontal line. Where x equals 0, that's not actually a solution to the differential. Y equals 2 is a solution to the differential. It's called a constant solution. And it's an extra solution on the one where you actually go ahead and you solve it. And it's a solution because when you differentiate it, you get 0. But when you put y equals 2 into the differential, you get 0. X equals 0 is the y-axis. So you'd also get a horizontal line at x equals 0, which is like this y-axis as well. Because when x equals 0, the differential equation will be 0. So all the way along there will be a horizontal line. Okay, now, if you wanted to look at where then when you go to solve this, I'm just going dy on dx equals x, y minus 2. 1 on y minus 2 dy equals x dx. Then you get ln y minus 2 equals x squared on 2 plus c. Y minus 2 equals e to the x squared on 2 plus c, which is e to the x squared on 2 times e to the c, which is a e to the x minus 2, because you just let e to the c equal a constant. Then y minus 2 equals that. So y minus 2 equals plus or minus a e to the x2. So y equals 2 plus or minus a e to the x2. And when y equals 2, that will actually be where a constant, that's called your constant solution, and is also a solution. But this here is your solution to the differential. Now the vertical line on the slope field will happen when the gradient is actually undefined. So say you had x minus 2 and y plus 1 on the bottom. So y plus 1 cannot equal 0. So y cannot equal minus 1. So what this means is the gradient of this is undefined. And when it's undefined and there's a 0 on the bottom, that will be a vertical tangent. So it's like this, along y equals minus 1. It could also be an asymptote. If that same point at y equals minus 1, if that is also on the denominator, when you integrate, then it ends up being like an asymptote, the undefined in the differential, but also undefined in the original solution. So the vertical line, like if you went to y equals minus 1, which is here, that needs to have like a vertical line. That's vertical lines all the way across at y equals minus 1, because that just means the gradient is undefined at that point.